Before we start with 2.3.3, let's review 2.2.3. That's what we're doing here, adding, subtracting, and then multiplication. So go ahead, complete these 6 on your own, then check back in for solutions. Pause. We're back. Remember adding, just combine those like terms. 8 minus 3 is 5, 3i. Excuse me. 3i minus 5i is negative 2i. 4 minus 2. So remember when we're subtracting, it can be helpful to distribute that negative. Zoom in a little for you. So we'll have 4 plus 4i minus 2 minus negative 6i, so plus 6, and then combine. 4 minus 2 is 2, 4i plus 6i is 10i. 12 plus negative 3 is 9. Negative 4 plus 2 is negative 2. So we have, 9 minus 2i. Over here, again, subtraction. So let's distribute that negative, like multiplying by negative 1. Negative 6 there. Negative 1 times 4 is negative 4i, combine like terms. Negative 9 minus 6 is negative 15. 8i minus 4i would be 4i. Over here, 1 plus 2 is 3. Negative 1 plus negative 1 is negative 2. Last one over here, another subtraction. So let's distribute that negative. So we have 12 minus 5i minus negative 12 would be plus 12. Minus positive 5 would be minus 5. 12 plus 12 is 24. Negative 5 minus negative 5 is negative 10. Okay. Now for multiplication. When we're multiplying, it's important to remember what imaginary numbers represent. We know I is the square root of negative 1, which means I squared, well, that's just negative 1. So when we're multiplying, we want to keep that in mind. So remember, where we go about that. If you want to pause the video and try it on your own, you're welcome to. Okay. So 4 times 3 is 12. 4 times negative I is negative 4i. 6i times 3 is 18i. And 6i times negative I would be negative 6i squared. So this is where that I squared equals negative 1 comes into play. We need to substitute in negative 1 for I squared here. And we can combine those like terms. Negative 4i plus 18i is negative 6i. Negative 6 times 1 is 6. And 12 plus 6 is 18, so I get 18 minus 14i. So there's a little extra step there with multiplication. Okay, you've got 3 more. Go ahead and complete those on your own if you haven't tried them already, and then we'll check back in. Okay, we're back. So distribute here. So 7 minus 2i plus 21i minus 6i squared. So combine those two like terms to get 19i. Negative 6 times negative 1, substitute that in for I squared, so this becomes plus 6. And 7 plus 6, well, that's 13, so I get 13 plus 19i. Continuing, 5 times 2 is 10. 5 times negative 3 is negative 15. Negative I times 2 is negative 2i. Negative I times negative 3i would be positive 3i squared. Combine like terms in the middle to get negative 17i. Substitute in negative 1 for I squared, so we get 3 times negative 1, which would be negative 3. 10 minus 3 is 7, so we get 7 minus 17i. Over here, 4 times 2 is 8. 4 times 3 is 12i. 4 times 3i is 12i, sorry. 5i times 2 is 10i. 5i times 3i is 15i squared. Combine like terms there to get 22i. Substitute in negative 1 for I squared. So we get 8 plus 22i minus 15. 8 minus 15 is negative 7, and we have plus 22i. And there we have it. Okay. So we want to keep that in mind for today as we do something called rationalizing the denominator, which we'll get to. But to start, let's talk about, let's look at some other multiplication problems. So let's do these two together. So we have 5 times 5 is 25. 5 times negative 6i is negative 30i. Then on to 6i. 6i times 5 is 30i. 6i times negative 6i is negative 36i squared. Let's combine those like terms. Negative 30i plus 30i, well, that's 0. Those cancel. Substitute in negative 1 for I, so we have 25 minus 36 times negative 1, so that multiplies to positive 36. 25 plus 36 is 61. Let's do the other. Negative 4 times negative 4 is negative 16. Negative 4 times negative 7i would be 28i. 7i times negative 4 is negative 28i. 7i times negative 7i is negative 49i squared. Again, our i's cancel. It's 28i minus 28i. That's kind of nice. So we have negative 16 minus 49 times negative 1 because we substitute negative 1 in. So that's negative 16 plus 49, since negative 49 times negative 1 is positive 49. And we get 33. So, both of our answers have no imaginary part. And let's look at both of these problems. Notice both of these problems have the same real and imaginary parts, just different signs. One positive, one negative, one positive, one negative. So what we can conclude here is that when we multiply two complex numbers but just change the sign in the middle, our imaginary parts cancel. What these two complex numbers are called complex conjugates. When you multiply two complex conjugates, so same real, same imaginary, just different sign in the middle, it will always give you a real number. So if we look here and want to write the complex conjugates, the complex conjugate, or the conjugate for these, you just change the sign. So the conjugate of 8 plus 7i would be 8 minus 7i. The conjugate of 7 minus 6i would be 7 plus 6i. The conjugate of negative 8 plus I would be negative 8 minus I. And the conjugate of 1 minus 2i would be 1 plus 2i. So not too bad. So what I'd like you to do is multiply out two of these. So you can pick two to multiply out. Multiply them by their conjugate. So like if I pick number 1 here, 8 plus 7i, I'm going to multiply that by 8 minus 7i. So pick two, pause the video, and then come on back. Okay, we're back. So for the first, 8 times 8 is 64. 8 times negative 7 is negative 56i. 7i times 8 is positive 56i, and 7i times negative 7 is negative 49i squared. Middle terms cancel because they're the opposite i's. 64 minus 49 times negative 1 because we substitute negative 1 in for I squared. Negative 49 times 1, negative 1 is positive 49. 64 plus 49, well, that's 113. Okay, and the same idea would apply for each of these. So I'm just going to go pretty quick on these so that you can check your answers. 49 plus 36. So for number 2, what is that, 85? Yep, 85 for number 2. For number 3, we should have 65. For number 4, we should have 5. 5 for number 4. Okay. So what we are going to do here now is we are going to do an operation that's referred to as rationalizing the denominator. So rationalizing the denominator basically just means, well, making the denominator rational. And the way that we do that is, well, first of all, the denominator just means the bottom part of a fraction. And to make it rational means to get rid of the imaginary parts. So the way that we rationalize the denominator is by multiplying by the conjugate. Because as we just saw, when you multiply by the conjugate, you get rid of that imaginary piece. It goes away. So that's what we'll do here. So to rationalize the denominator, we multiply by the conjugate. So let's look at this one. Let's multiply by the conjugate. So the conjugate of 2 plus 5i would be 2 minus 5i. But if we're multiplying the bottom by 2 minus 5a, we also need to make sure to multiply the top. So let's go ahead and multiply here. So up top we have 3 times 2 is 6. 3 times negative 5i is negative 15i. Then down below, 2 times 2 is 4. 2 times negative 5i is negative 10i. 5i times 2 is 10i. And 5i times negative 5i is negative 25i squared. Keep on going. So those i's in the middle cancel. So we have 4 minus 25 times negative 1, since we got to substitute negative 1 in for I squared. Negative 25 times negative 1 is positive 25. So we get 29 below and 6 plus 5i above. So this is called rationalizing the denominator. We've made the denominator rational now because there is no imaginary part. What the heck is happening? Sorry, this isn't plus, should be minus 15. Lost in my own handwriting. All right. Okay, let's look at number 2. So for number 2 here, again, we want to rationalize the denominator. So that means you multiply by the conjugate, I suppose we could add to this, in the denominator, or of the denominator, the conjugate of the denominator. So our denominator here is 5 plus 4i, so we multiply the top and bottom by 5 minus 4i. Making sure to FOIL it out or multiply it out. So up top, 2 times 5 is 10. 2 times negative 4i is negative 8i. 3i times 5 is 15i. 3i times negative 4i is negative 12i squared. Down below, 5 times 5 is 25. 5 times negative 4i is negative 20i. 4i times 5 is 20i, and 4i times negative 4i is negative 16i squared. Whew, long one. So, up top, things don't cancel, notice, because we didn't multiply by the conjugate of the top, which is okay. That's all right. We can have imaginaries up top. So negative 8 plus negative 15 is positive 7i. Substitute in negative 1 for I squared. Down below, those i's cancel, and we get 25 minus 16 times negative 1. So again, substituting that negative 1 in for I squared. And then distributing. So negative 12 times negative 1 is positive 12. 25 minus negative 16 times negative 1, positive 16. And then simplify. 10 plus 12 is 22. 25 plus 16, well, that's 41. There we go. Okay, rationalize the denominator means multiply by the conjugate of the denominator. All right, I'm going to leave you with 2 more problems. Please give both of those a try on your own. Then pause the video and check back in when you're ready. Pause. Okay, we're back. So conjugate here would be 4 minus 3i, making sure to multiply both the top and bottom. So up top, that leaves us with 2 times 4 is 8. 2 times negative 3 is negative 6i. 5i times 4 is 20i. And 5i times negative 3 is 15i squared. On the bottom, 4 times 4 is 16. 4 times negative 3i is negative 12i. 3i times 4 is 12i. And 3i times negative 3i is negative 9i squared. Combine some like terms. So negative 6i plus 20i, 14i. Substitute in negative 1 for I squared. Those i's cancel. We have 16 minus 9 times negative 1. Up top, let's simplify. Negative 15 times negative 1, positive 15. Negative 9 times negative 1, positive 9. So we get 8 plus 15 is 23. Sorry, I'm losing you. 8 plus 15 is 23. 16 plus 9 is 25. Cool, cool, cool. Last one. Multiply top and bottom here by 8 plus I, because that would be the conjugate. 2 times 8 is 16. 2 times I is 2i. 6i times 8 is 48i. 6i times I is 6i squared. 8 times 8 is 64. 8 times I is 8i. Negative I times 8I is negative 8I. Negative I times I squared is negative 8I squared, or negative I squared. 2I and 48I is 50I. Plus 6 times negative 1. Negative 1 in for I squared. 8I and negative 8I cancel, and we have minus, substitute in negative 1 for I. So we've got 16 plus 50I minus 6 over 64 plus 1. Keep on going. 16 minus 6 is 10. Over 64 plus 1 is 65. So we've rationalized. In this case, kind of tricky. We could simplify a little bit. Notice all of these are divisible by 5. So what I could do is I could factor a 5 out of the top here. So meaning divide both by 5. Sorry, that would be 10 then. So 10 divided by 5 is 2. 50 divided by 5 is 10. Here, 65 times 13 is 5. And then we can cancel those. So we get 2 plus 10I over 13. That'd be our most simplified. I would accept this as an answer because the focus is on rationalizing, not simplifying. But that would work too.